for today we're going to be covering coterminal reference and special angles. So if two angles in standard position have the same terminal side, they are called coterminal angles. So on this example, if you notice here, both of them stop right here. So they just start in the same position, which is your initial side, but the direction of the angle, so this one's going in a positive direction and this one's going in the negative direction. So the numbers are different, but the position is the same. So these are considered coterminal angles. So here it says sketch each angle in standard position and give two angles, one positive and one negative, that are coterminal to a given angle. So first we have 500. Okay, so we're going to start here. Remember, we start at 0 degrees, and then 90, 180, 270, oops, 360, but that's still not enough because we're going all the way to 500. So 360 plus another 90 is going to give me 450, plus another 90 is going to give me 540. Okay, so that means that 500 is going to land in between 540 and 450, and it's probably going to be closer to, let me see, 40 away, 50 away, it's going to be closer to the 540, just a little bit. Okay, so then here when we draw our angle, it's going to start here, and it's going to come all the way around once, and then go back this way. Okay. So then here it says we're giving two angles, one that is positive and one that is negative. Okay. So the positive angle would be just this little section here. So if we took away that full rotation that it gives, so if I were to do 500 minus 360, that gives me 140. Okay, so that's going to be one of them, 140 degrees. And then the next one would be the negative angle. Okay, so it said one positive and one negative. So the negative angle would be from the initial side, and it would come around this way and in here. That would be the negative angle. So if I got 140 when I subtracted, I'm going to go ahead and subtract 360 one more time. So I'm going to take away one full rotation, and that should give me, or should get me into the negatives. So 140 minus 360, that gives me negative 220. So that angle would be negative 220 degrees. All right, the next one, so this one is negative 60. Okay, so negative 60, this would be considered negative 90. So negative 60 would be right here. Okay. Let's see. It goes in this direction, so we need to give one positive angle. So I'm going to take negative 60, and I'm going to add one full rotation. So I'm going to add 360, and that gives me 300 degrees. So that means from here to here is 300 degrees. So that's one positive. And then if I'm going to give one negative, I'm going to have to take my angle, which is negative 60 degrees, and I'm going to subtract 360. That is going to give me negative 420 degrees. So then if I were to draw that on here, it would make one full rotation. That's 360 plus a little bit extra. It would give me negative 420. Okay, so the next one here, it says pi over 4. So I know I showed you guys how to change it to degrees if you're not comfortable with the pi over 4. So remember, from here to here is pi. So if I take this section here and cut it into fourths, so 1, 2, 3, 4, we are only worried about one of the pi. Okay, so 1 over 4. So I can go ahead and erase this. So this is my angle here, pi over 4. Now we're doing one positive and one negative. I did it wrong color. So one positive is when we add one full rotation. So in degrees, when we add one full rotation, that is adding 360. But in terms of pi, you would add 2 pi. So in my calculator, I'm just going to do 2 plus 1 over 4. And that's going to tell me how many pi's we have. So that is going to give me, in a fraction, of course, that gives me 9 over 4. So it'll be 9 pi over 4. Okay, so that means that if we were to go here and we would add one full rotation, it would go around once and then end here. Okay. Now, next we're going to do the negative angle. So we're going to take pi over 4 and we subtract one full rotation. So we subtract 2 pi. So in our calculator, we're going to do 1/4 minus 2, and that'll tell us how many pi's we have. So 1/4 minus 2 as a decimal is negative 7 over 4. So it's negative 7 pi over 4. So that would be my negative angle. And remember, your negative goes in the opposite direction. So it goes around this way. Okay, notice how they all land on the same spot. Okay, that's why they're coterminal. Okay, this last example, so negative 2 pi over 3. I'm going to go ahead and draw it. So it is cut into thirds. So here, I'm going down to the bottom because it's negative. And I cut into 3 equal pieces. All right, and then from there, it is 2 of the pieces. So 1, 2, it would end right here. So let me go ahead and erase my little pi that I made. And so this angle is the one that they give us, which is negative 2 pi over 3. So to find two coterminal angles, the first one, I'm going to take negative 2 pi over 3, and I'm going to add one full rotation. I take that same angle, negative 2 pi over 3, and we subtract one full rotation, which would be 2 pi. Okay, so pretty much for these numbers, all you're doing is adding and subtracting either 360 if it's in degrees or 2 pi if it's in radians. So I'm going to go ahead in my calculator. Remember, I'm going to take the fraction part, which is negative 2/3, and I'm going to add 2. That's what I'm going to put in my calculator. And that's going to tell me how many pi's I have. So negative 2/3 plus 2. I change it to a fraction. It is 4/3 pi. So that means that's this angle going this way. Okay, this one where it's negative, so that's one of my answers. This one where it's negative, I'm going to go ahead and take negative 2/3, and instead of adding 2, I am going to subtract 2. I change that into a fraction. It gives me negative 8 over 3. And that tells me how many pi's I have. Okay. So this one is actually going around once and twice in the negative direction. That's it. All right, so the next one, associated with every angle drawn in standard position except quadrantal angles, there is another angle called the reference angle. The reference angle is the Q angle formed by the terminal side of the given angle and the x-axis. Reference angles may appear in all 4 quadrants, and the angles in quadrant 1 are their own reference angles. For example, so whenever you're doing reference angles, I suggest that you do highlight the x-axis because you need to make sure that you need to see how far away are you from the x-axis, okay? I don't want you guys to get it confused from the y-axis. So this tiny little angle here, which is 60 degrees, if your terminal side is in quadrant 1, then this is going to be your angle. Okay. So here, if it's in quadrant 2, so here I am in quadrant 2. Remember, this number is 180. To figure out what my reference angle is, which is this angle that's with the x-axis and the terminal side, we do 180 minus 120. Okay, because the angle they gave us is 120, and our reference angle would be 60. Okay. For example, here again, I'm going to highlight the x-axis, and so your reference angle is from the x-axis, the x-axis and the terminal side. Okay, so the shortest distance. So here it is 60. The way they come up with that 60 is they take 240 and they subtract 180. Okay, because from here to here is 180. That gives us the 60. And then the last one here, it's almost one full rotation except for this little piece right here. So the way that they find that is by taking one full rotation, which is 360, and then they subtract this angle here, which they tell us is 350. And that gives us 45 degrees. So remember, that is always going to be your shortest distance from your x-axis to your terminal side. So those are called reference angles. Now for reference angles, they use the little symbol. It looks like this, like a little fish. Okay, that's a symbol for reference angle. So here it says, sketch each angle theta in standard position and find the reference angle A, labeled theta and alpha. Sorry, not A. Remember, the reference angle is measured from the terminal side of the original angle to the x-axis. Okay, so first we're going to draw this angle. So theta equals 135 degrees, which would be, this would be 180, this would be 90. Okay. Oh, I should have used a different color here, sorry. Let's use blue. Okay, so we're just going to draw this one. This is 90, this is 180. So 135 would land right smack in the middle of those two numbers. Okay, so this is my theta. Your reference angle is going to be the smallest distance from the x-axis. So we're going to use the negative x-axis because it's closer to my terminal side and my terminal side. So this angle right here. That's what we're trying to figure out. So we take 180 and we subtract the 135. And that gives us 45. So that means that our reference angle is equal to 45 degrees. I just used these two colors. Sorry, guys. All right, the next one here is theta equals negative 210. So here is our initial side where we start. Oops. I did that. And then this would be negative 90, negative 180, negative 270. So then negative 210 lands in between 180 and 270. And so then our reference angle is going to be the shortest distance from the x-axis. Remember, always the x, never the y. And so here is my x-axis and the shortest distance from 3. So this is the angle that we're looking for. Okay, so if I were to do negative 210 minus a negative 180, okay, this ends up turning into a positive and it gives me negative 30. Okay. Now the rule is our reference angle does have to be positive, so I'm just going to put it as a positive because that's going to be the actual measurement of this angle, which is 30 degrees. All right, the next one here we have 290 degrees. So again, we're going to draw this first. So this is 90, 180, 270, 360. So 290 is going to land in between 270 and 360. So here's my angle theta. Now our reference angle is going to be the shortest distance from the x-axis. So we're going to use a positive x-axis because it's closer to the terminal side. Okay, so that's going to be my alpha. So to find that, one full circle is 360. We subtract our angle, which is 290, and that gives me 60, 70 degrees. So that is going to be my reference angle. All right, the next one here, our angle is 80 degrees. So here would be 80 degrees. It'd actually be closer to the, since this is 90, it's going to be pretty close to it. So about right here. Okay, this is my angle theta. And so our reference angle in the first quadrant is itself. Okay, so right here it's 80 degrees. So alpha is also equal to theta, which is also equal to 80 degrees. All right, so now we have these in terms of pi. So this is 4 pi over 3. So I'm going to go ahead from here to here is 1 pi. Okay, I cut it into thirds, okay, because it's divided by 3. And this is only 3 pieces of pie. I still need one more piece, which would be right here. Okay. So here is my angle. Just erase these because we don't need that. Or you know what, we might need it. Oops. Sorry, 1, 2, 3. So there's 4 pieces of the pie. Our reference angle, so this is my angle theta, our reference angle is going to be the shortest distance from here to here. Now this one is only 1 piece of the pie. So then our alpha is going to be 1 pi over 3. Okay? The 1, we don't need it there in front, it becomes invisible, so it'll just be pi over 3. And that's it. Now, if you wanted to solve it mathematically, all you gotta do is take pi and subtract it from the 4 pi over 3. So you do 4 pi over 3 and subtract that pi. And in your calculators, you would put 4/3 minus 1, okay, because it's only 1 pi. And that'll tell you how many pies you've eaten. And then once you subtract it, it should give us what we got here, the pi over 3. All right, the next one. So this one is negative 5 pi over 6. So because it's negative, it is going to go in this direction. It's over 6, so I'm going to have to cut this into 6 pieces. So something like this. 3, 4, 5, 6. Okay, and it's 5 out of the 6 pieces, so it's going to go, this is 1 piece, 2 piece, 3 piece, 4 piece, 5 pieces, so right here. Now our reference angle is going to go from here to here. Our reference angle is going to be the shortest distance from my x-axis to my terminal side, so it will be this little piece right here, which is only 1 piece of the pi. So it's only 1 pi over 6. Okay, if you wanted to solve it mathematically, just like we did on the last one, this one would be considered negative pi. So you'd take negative pi and you would subtract the negative 5 pi over 6. Okay, 2 negatives make a positive. You put this in your calculator and it should just give you pi over 6. Alright, so here it says for the rotation 500 degrees, find the coterminal angle from 0 to 360, the quadrant, and the reference angle. Okay, so here let's go ahead and see 500 degrees. I believe we already graphed this one. So we have 0, this is 90, this is 180, this is 270, this is 360, then this is 450, and we add another, this would be 540. So 500 degrees would land about right here. Okay. So it starts here, it comes around once, and then stops here. So to find the coterminal angle, we're going to go ahead and take the 500 degrees, and we're going to subtract 1 full rotation away from it. So 500 minus 360 gives me 140. So this angle from here to here is 140 degrees. So here the coterminal angle is 140 degrees, which lies in quadrant, so it lies in quadrant 2. Just in case you don't remember, this is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. The order never changes, it always stays like that, okay? Positive or negative, the quadrants are always numbered the same. And then it says with the reference angle of, so we need to find the reference angle, which is this little piece here from the x-axis to the terminal side. So the way that we find that is we take the 140 and we subtract it from 180. So 180 minus 140 gives us 40 degrees. Okay, so let's try another one. It says for the rotation negative 282, find the coterminal angle. So we're going to do the same thing. So this is 0, this is negative 90, this is negative 180, negative 270, and then negative 360. So 282 is going to land right in between 270 and 360, negative 270. So it comes around once. Whoops, I went too far. Okay, so we're going to find the coterminal angle. So we're going to take the negative 282 and we're going to add 360 to get it to a positive coterminal angle. So negative 282 plus 360 gives me 78 degrees, which would be this angle right here. Now because we landed in the first quadrant, okay, 1, 2, 3, and 4, we do not need to solve for the reference angle. It is its own reference angle. It's a distance from here to here, which is just 78. All right, and I believe that's it for me. Thank you guys. If you guys have any questions, you guys can go ahead and let me know. Thank you guys. Bye.